Hello, this is Dr. Scott Dennstaedt, founder of EZWxBrief, your best online source for aviation weather and education. Welcome to episode 7 of EZWxChat, a program to talk about anything related to aviation weather. In this episode, I'm going to focus a little bit less on the EZWxBrief application and focus on one particular forecast chart that many pilots are familiar with called Prog Charts. We're going to do somewhat of a deep dive on this particular chart so that you can gain an appreciation, understanding for how to properly use it. Now, Prog Charts are issued by the Weather Prediction Center located in College Park, Maryland, and they are issued multiple times throughout the day. It tries to tell you what's going to happen and how various different major weather systems are going to evolve over the conterminous U.S. So I like to spend a fair amount of time with all my students, getting them really comfortable with understanding what it's telling you and essentially what it's not telling you, and give you a few tips on how to use it successfully. Now, all pilots should be spending a fair amount of time understanding that big picture. And if you've ever done any training with me, you know that I'm very much adamant about as much as possible about getting a great understanding and a complete understanding of the big weather picture. And this is just one of the products to use to do that. Now, you'll find that the Prog chart, for the most part, doesn't tell you on the surface here how to really interpret it. And I'm not talking about interpreting frontal systems and highs and lows and the weather itself. I'm talking about interpreting how to use it from the standpoint of, what is this particular area telling you in terms of precipitation? Is it precipitation over a period of time, at a single time? How do you really kind of get yourself wrapped around the different shades of colors and understanding that? So that's the kind of thing I'm going to be focused on here. Not necessarily telling you how to use it from a weather perspective, but more the administrative side of the house, so that you can use it within its design limits and understand essentially, again, what it's telling you. This is a Prog chart, so it's a forecast, whereas when we look at something like the surface analysis chart here, looks kind of similar. A lot of the same things. You can see highs and lows and lines of constant pressure or isobars. You can also see information in terms of station models here. You can see the various station models on the chart, which are typically at airports, representing the weather at that particular airport in a graphical depiction. Now, it's always important to kind of start your pre-flight briefing from this particular chart and then work your way as a segue into the Prog charts. To get a good understanding of kind of where the weather is going, you need to understand where it has been. So if you look at the most recent 12 to 24 hours of charts here, you'll get a pretty good understanding of kind of how the weather is evolving or has evolved over the last 24 hours or so. And then once you've got a pretty good depiction of that, then you can kind of work your way into the Prog charts. In EZWxBrief, all the Prog charts are available for you in the Imagery. Now, the first thing to understand is that there are what are called short-range Prog charts and longer-range Prog charts. Of course, the short-range Prog charts are those Prog charts that are going to be valid in the next day or two or three. Push the slider over, you'll see that these Prog charts eventually start to look different as you get further out in time. You'll notice by the time we get to this is the day 3 Prog chart. What you'll notice is that these are the longer range Prog charts, and they're issued basically for 12Z every day out through 7 days. So you have essentially, you're dealing with day 3, day 4, day 5, day 6, and a day 7 forecast. Now, for the most part, they all look the same, but in many respects, as you get out further in time, obviously the uncertainty is higher. And so as a result of that, you're likely to see more situations where the precipitation areas may end up being much larger and certainly not as focused as they are for Prog charts that are valid, let's say, in 6 hours or 12 or 24 hours from now. Let's start with the basics of Prog charts, kind of Prog chart 101. So when you look at the Prog chart itself, there's a lot of information on it that includes elements such as high and low pressure centers that you see here, so they're marked as an H or an L. You'll see cold, warm, occluded stationary fronts associated with major weather systems that are also depicted as well. And you'll also see other features such as surface troughs. The last thing that you see on this chart are colored areas, which are areas of forecast precipitation. And specifically, it's precipitation type, whether it be rain, snow, mixed, ice, or thunderstorms, convection. Now you'll notice that for the most part, the precipitation that you see here covers the entire conterminous U.S. here, but it does not go outside of the U.S. And we'll talk about the reason for that in just a bit. So in this particular situation, the precipitation will stop at the U.S. border, whether it be for Mexico or Canada, and it only goes out so far along the coastlines. And that's true of the short-range Prog charts as well as the longer-range Prog charts. But you'll notice that the other features, such as the highs, lows, isobars, and the frontal systems, do expand outside the conterminous U.S. into Canada, Mexico, and off into the oceans. So those fronts, those highs, the lows, those isobars are actually forecasters at the Weather Prediction Center. You see a forecaster's name at the bottom here. Those are the forecasters that are taking a lot of input from typically forecast models and based on their own experience. And they push that particular forecast out here on the Prog chart. The colors, or precipitation type, basically are the type of precipitation, whether it be rain or snow or mixture, that is expected to reach the surface at the valid time on the chart, in this case 18Z. That forecast is actually produced by your local weather forecast offices. So when you look at this particular chart, you're looking at not just one forecaster's view of the weather, but potentially well over 100 forecasters that have made their mark on this particular forecast. And I can show you here, if you look at the Aviation Weather Center's website, and I'll pull this over, you can see that every one of those colored polygons in the U.S. is a weather forecast office. We call that a county warning area. So here in Charlotte, where I live, I'm under the Greer, South Carolina weather forecast, which is the Greenville-Spartanburg weather forecast office, and it covers a specific area. And so when that particular forecaster pushes a forecast for precipitation type out for that county warning area, then that goes into a database called the NDF, the National Digital Forecast Database. And from there, the Prog chart pulls that particular precipitation type onto the Prog chart itself. And so as a result, what you're getting is a forecast from many different forecasters around the country. There's some good things and bad things about that. One of the good things about it is essentially any of those forecasters that are putting in those precipitation type forecasts are also the same forecasters or in the same office that are issuing the terminal aerodrome forecast, the TAFs. So in effect, the weather you see on the Prog charts in the TAFs, at least during the TAF's valid time, which is 24 or even up to 30 hours, should match up pretty darn well. And there's some caveats to that that I'll explain in a bit. But that's the good part about it. The bad part about it is that you'll see that some of these forecast offices have pretty hard boundaries right at the state boundaries, for instance, especially Atlanta, or you'll see Albuquerque as well. And often when you look at the Prog charts for those particular areas, sometimes you'll see, in some cases, you'll see that the boundaries tend to be kind of hard edges to the forecast based on the boundaries of that forecast area. And obviously we know that weather does not obey geopolitical boundaries, but sometimes, again, they're supposed to be talking to each other, making sure that doesn't happen, but sometimes you'll see some weirdness where you'll see some differences of opinion about what's going to happen in a particular area, and it tends to cut off right at that boundary. Probably not a horrible thing, but ultimately, certainly it does pop up from time to time, and you essentially need to be aware of that. So the most important aspect of this is to note that this is a probabilistic forecast. It's a probabilistic forecast based on two levels of probability. They call it chance or likely. It doesn't really classify in this particular chart what that boundary is between chance and likely. However, I can tell you what it is, and essentially that anywhere you see a lighter color, whether it's lighter green or lighter blue or mixed or ice, that's going to be the case where you're dealing with a probability of 15% all the way up to 55%. So 15 up to 55%. Anything that's dark color, dark green, dark blue, is a probability of 55% or greater. So the darker colors typically mean a higher probability, and we translate that into a higher confidence the forecaster has that there will be that precipitation type reaching the surface. And the other key element here is at the time that's shown on the chart. At the time that it's shown here on the chart. So this is not a forecast that's covering a time range such as 18Z to 0Z. It's actually telling you about precipitation coverage, where that forecaster is thinking it will be precipitating at that particular time. Now we do know that, again, this is a probabilistic forecast, so the lower probability areas, like you see maybe here in Pennsylvania and Maryland and into West Virginia, you may be able to, at this particular time, 6Z, fly through that area without seeing precipitation, may not even see any clouds. But yet, the forecaster is not certain enough to make it completely white. Instead, they feel that there is some chance, even as low as a 15% chance, of precipitation reaching the surface in that area. So the way to think about that is, again, look at, like, say, for instance, a NEXRAD image. So this is the MRMS composite reflectivity. And if you were to draw a big circle around all the precipitation areas, so if I were to take a circle and draw it around this area here in southern Texas, if I were to draw this big area here in the Midwest and kind of the lower Mississippi Valley, and kind of encapsulate or capture as much of that precipitation area as you can without drawing really, really specific lines around every single cell, that's kind of what the Prog chart is telling you. So if you were to make this kind of wide sweeping area here where you see the precipitation, there's lots of areas in here that are not precipitating at that time. But from a forecast perspective, they try to do this with a little bit broader brush, because again, this is a forecast for the future. So they're looking at, what's going to happen over the next, in the next 24 hours, the next 30 hours, 36 hours. So it can't be so specific and so detailed. Instead, they have to have a broad brush of probabilities. So that allows you to really quickly see where the coverage of that precipitation type is expected. And also, if we look at the Prog charts back here again, and we look at one more feature here, and that is the hatched regions. So the hatched regions essentially mean that the forecaster expects that particular precipitation area to be convective. And again, it doesn't mean necessarily you won't get a thunderstorm or a convective, embedded convective outside of that. It just says this is the highest probability areas you'll see convection. So in the center part of Texas here, not much a chance of precipitation at all. There's kind of a hole, if you will. But all around that, we see a chance of convection. And in this case, the hatched areas in the light green mean it's likely a 15% up to 55%, except where you see the darker red areas, and that's a more likely case, so you're dealing with 55% or greater chance, and you could be dealing with severe weather. So we know that severe thunderstorms are kind of rare, so when the forecasters are making their forecast for convection and they think it's going to be severe, they have there's a stronger signal in the forecast tools they're using to go ahead and produce a forecast for severe weather, so therefore it's usually a higher probability. That does not necessarily mean that everywhere in this region that's dark red will be severe thunderstorms. It's just a more likely case, and some of those storms could be severe. And kind of conversely, if you're in an area where there's a dark green area or even light green, as the case may be, you could still have a severe thunderstorm in those regions. It's just not as likely to be the case. So this is kind of the overview of this particular Prog chart. I would say in most cases this gives you a pretty good idea of what's going to happen in terms of the evolution of major weather systems. But there's a lot missing here because there's a lot of these Prog charts are issued and then there's a 6-hour kind of jump in each forecast, and eventually that jumps to 12 hours, and then as you get to the long-range Prog charts it jumps 24 hours. So there's a lot of time in between those Prog charts that you need to account for. So it doesn't give you every aspect of what's happening weather-wise, because ultimately you could say be in a situation where, let's say, an area of weather is expected to develop around 19Z. This is valid at 18Z. So let's say somewhere in central part of Tennessee something is expected to develop and the forecasters know it, but yet it will potentially dissipate before 0Z. Then it will not show up on this Prog chart because it's actually starting and finishing in between those two times. So I always tell my students to make sure that they look at other products, and specifically one of the products I use a lot to do this is the 6-hour QPF, which is a quantitative precipitation forecast, which in this case it's over a period of time, a range of 6 hours in this particular case. 6 hours is a great short time frame because it happens to be very coincident with the 6-hour differences in the Prog charts, but also the fact that over a 6-hour period most of us are making flights that kind of are within that 6-hour time frame. So it's always good to kind of balance between the Prog chart precipitation and the precipitation on the QPF, Quantitative Precipitation Forecast. And one more hint here of how to use this is that this particular product that you see here, this QPF, is not a probabilistic product, but in general, the forecasters also at the Weather Prediction Center will typically only provide a forecast for precip, again, reaching the surface, if the forecaster is at least 50% confident in that 6-hour window there will be precip occurring. If they don't have that kind of confidence, then it won't appear on that. So this particular forecast, generally speaking, is a forecast that kind of filters out all those low probability events, which I like. Because when you look at the Prog charts, especially during the summertime, which you'll notice the Prog charts tend to sometimes have these really big, wide sweeping areas of precipitation, again, we may find that we can fly through these lighter green areas with little or no trouble, or maybe we have to divert around some cells here and there. Or in some cases, I've seen situations where I've actually flown from point A to point B and not even seen a cloud, much less any precip. But nevertheless, it's still a warning, or at least an advisory, that there is the possibility of convection. So when you are looking at this from a longer range perspective, take all that into account. And certainly don't cancel a flight just because you've got this hatched area that's in your flight path. Instead, further quantify this as you get closer to your departure time, and then look at products. One of the best products to look at from this standpoint is to look at the convective signets, and specifically the convective outlooks, because in this particular case, this larger convective outlook area, kind of in the gold or tan color, is a region where forecasters at the Aviation Weather Center have determined that there is the possibility that thunderstorms or convection will develop that meets very specific criteria used for aviation purposes. So in this particular scenario, we can depend on, that if any convection develops, it will likely be in this area, and that would be potentially dangerous for pilots, especially general aviation pilots, but for any pilot flying through that region. And of course, the convective signets that you see, the red polygons, are regions that are telling you that there are active areas of convection or thunderstorms that meet very specific criteria, again, hazardous to aviation. When you look at the Prog charts in general, you're trying to get the big picture out of this and understand and assess what's going to happen. But it's, again, not the be-all to end-all. You still have to understand other elements of what's driving this weather. And you can certainly provide other forecasts, convective forecasts or other precipitation forecasts, to help kind of round this out. And so I would recommend that everybody spend at least some amount of time looking at this before any particular flight. And it goes out, again, to 7 days in the forecast, so you can watch it kind of every single day up to the point where you're planning to fly. And then you can make some adjustments. So it's always good to see the case that where if you were flying here from, let's say, Pensacola all the way up to, let's say, Baltimore, and you're leaving here at 0Z, you're likely to see a pretty good chance of little or no precip along that route. There could be other issues, turbulence, icing, there could be low IFR conditions. It doesn't tell you those kind of things. But what you're kind of looking for is, are there any areas of precip in my way? Because we know precipitation, things like IFR conditions, mountain obscuration, convection, thunderstorms, icing, poor visibility, low ceilings, all those kind of things tend to hang in and around areas of precip. So it's real important for us to pick that out. And the Prog charts provide us with a really nice way to do that. So that's the end of episode 7. So for now, enjoy the simplicity of EZWxBrief.